Hello world, it's Andrew Engineer, right? So in our new video of today, we are going to talk about shear reinforcement. In this short video, we'll just explain how to get the diameter of a shear reinforcement or transversal reinforcement. Okay. How do we do that? Why solving this exercise is simple because most often for young engineer or young student in civil engineering or passionate of civil engineering, they always wonder why is it that most often it's just diameter 6 RL wrong list, which means wrong list, diameter 6. Why is it that it's always wrong list? Okay, why is it always most of time diameter 6 millimeter? Okay, so to get the diameter of the transversal reinforcement is as simple as possible as this. You have the transversal reinforcement diameter is simply equal. There is a relationship which link the longitudinal reinforcement and the transversal reinforcement. So you have to take the diameter of the longitudinal reinforcement, okay, the maximum diameter of the longitudinal reinforcement divided by what? Divided by 3 to obtain what? To obtain the diameter of your transversal reinforcement. In the case here where we have, for example, a 12 millimeter, let's assume that it's a HA 12 millimeter of diameter, like you can see here, dividing it by 3, okay, 12 millimeter by 3, we will simply have a 4 millimeter diameter. Okay, so you will see that the transversal reinforcement diameter is 4 millimeter, whereby on the market now or on the commercial zone, we don't have a diameter of 4 millimeter. The standard diameter are starting for 6 millimeter, 8 millimeter, 10 millimeter, and so on so forth. Okay, so now when you obtain such an answer, the simple thing to do is to take the nearest value to your value which is being commercialized. Okay, so here we'll consider the diameter of the transversal reinforcement to be what? To be 6 millimeter. This is the diameter that we'll buy on the market. Okay, now you will simply see that for a diameter 12, you have 6 millimeter of diameter, or you even have 4 millimeter. That's the exact value. So it means that even if you go to 14, you will still be at 4 point something millimeter. You see that that's why now that most often we have the diameter 6 has transversal reinforcement, because it's only when you go up to, for example, diameter 20 or 20 millimeter of diameter that you can divide by 3 and you obtain approximately 6.6 something, 6.67, okay, which is already greater than 6 millimeter diameter. And in the course of, you understand that the effort, you cannot work with a diameter of 6 millimeter in this scenario, simply because the value obtained here, the exact value is greater than the value than the 6 millimeter. So you would take again the closest value to closest commercial value to your answer, which in this scenario will simply be equal to what? Will simply be equal to 8 millimeter of diameter. So you will be working with the 8 millimeter of diameter. Okay, in this case, for a longitudinal reinforcement having 20 millimeter as maximum diameter of the longitudinal reinforcement, you will be working, for example, with a 8 millimeter diameter. But also there's also at times to you have to check the shear forces. Okay, you have to check the shear forces acting on the structural element to ensure that the diameter that you have chosen will actually be able to withstand that shear force. But basically, that's how you obtain the diameter of your shear reinforcement. Thank you so much for watching. Don't forget to leave a like and to comment the video, and also share the video. Even subscribe to the channel to give us support or to give us more strength for more. Okay, thank you so much. It was Andrew. See you soon for our new lesson.